How did you get your Wi-Fi to work?
Major strike. Wildlife. I'm very sorry. I'm sure you understand.
I did forget.
So good morning. I hope Joshua can hear us. At least the course is being recorded. I have no idea if the audio is any good. I have no idea. And the outro for solstice, I need a crash course on solstice because then you're really good. Hello. So good morning. I'm supposed to try to I'm supposed to show you a PowerPoint.
You can share screen.
Only if PowerPoint is open. Let's see if we can open the PowerPoint. So guys, as you realize, this course is being built as we go. Your input this year for any kind of lab assignment and finding you have on wildlife management is useful. Building some kind of a database. Before I go into the nitty-gritty of ecological concepts with chapter 1B that has as of 4 to 10 this morning, 48 slides. No, I didn't make up 48 slides. Before that, then I'd like to get some input. I don't know if anybody wants to, if I say wildlife, I need to find out what you have in mind. Basically, I'm trying to see why you're taking a free-credit course in wildlife management. So I want to know what wildlife and what you have in mind in terms of management. I think you already know enough about management, either extension control, conservation, pest control, and so on. What kind of wildlife you have in mind? Anybody wants to speak up? Okay, sure. There's nothing like bringing silence to a room when you just ask a question. Yeah, but what kind of wildlife? What do you have in mind? Do you think great white shark? One of the specific species that you have in mind? Or fish, birds, mammals, invertebrates, anybody know? Fish, birds. Hey?
Lake sturgeons.
Lake sturgeon? Sure. Yeah, pretty fascinating. Anything else? Anybody else?
Blackbird,
Did I?
like blackbird.
Blackbird?
Yeah.
Cool. Yeah, badger. Badger? Oh, I didn't talk to weasels yet. Oh, they don't get me started on that. And the badger is the oddball for sure. And weasel kind of sure doesn't look like a weasel too much. Crazy beast for sure. There's nothing like asking for a letter of reference from me to get 95% out in this course. They have their own population factors that they can study in genetics, everything they know the first cousins. Very cool for publishing genetics. They're resident, they're colonies, so you find one, you find one. So the question is, you have to be related in order to be part of the colony. Are they all related? Cool. See? We got it. guys. No wildlife?
Wolverines.
Oh, it's, yeah, Wolverine, emblematic, for sure. Very Nordic, right? So, people travel the world just to see a Wolverine every year. Fun in Alaska, a lot of money with tourism because of that. White Forest has a population, resident population of 3,000. And to 15,000. So every pub, all up there, I mean, it's created more to tourists who, whether, rock climbing. Good for that. Yeah.
Zebra mussels? Zebra mussels?
Hey, that's all right. Now we're talking zebra mussels. So, one of the vertebrates that I forget. Zebra mussel, very interesting bivalve, I guess we call them. Mollusk. And their history is, I think, as far as I'm concerned, the biology is sort of straightforward because it's a fairly simple animal. I mean, there's not too many ways of being, you can be different wolves, small ones, rats, and so on, but in the mollusk, the biology is pretty straightforward. So the story about the zebra mussel definitely the human interaction. Yeah.
Big cats.
Big cats? Yeah. Yeah. Name one. The lion and the tiger, yes. Very different, right? Lions, the story and the city, I'm an ecologist, I'm a biologist, so right away I'm thinking of the biology of the animal first and then the human interaction. So lions, the determinant is the fact that they work in tribes. So just biologists study the pride ecology. In other words, what are the chances of a pride being successful in raising cubs? So the unit becomes a pride. So we don't care so much about the 3-year-old female in there because she belongs to the pride and she brings food home. She goes to the basics every now and then. Brings some or from the antelope. The tiger, on the other hand, is a similar animal, although it's totally solitary and territorial, therefore you can't use the saw tiger. Too close. And so see, the next one is very slim. But they're solitary and territorial, that means they hate each other. That's males try to get closer to the female. That's a different story. We could get into that. It becomes really species specific. There's groups like that. Animals, they still have to breed. So solitary is not the best way to do it. So definitely there's got to be an attraction between males and females. So there's solitary territory, yes. Between females, yeah. Between males, yes. But when it comes to males and females, they'll pass each other. Therefore, the male always knows that it's an antelope to the right and there's a female to the left. If there's only an antelope, not so good. Or they think they're not so good. So they need to travel a lot just to do that. Anything else?
Koalas and pandas.
Yeah. I don't know too much about the growth rate, the breeding rate of koalas. I'd be interested. This is a marsupial. Suddenly, we're looking at a very different biological system for reproduction. Therefore, we don't know the viability of the newborn, for example. So, in terms of rebuilding, say, because koalas are emblematic for conservation, very few numbers are declining, habitats going down. People are, and then recent fires, raise your hands, anybody heard of fires in Australia? Good thing. So, yeah. It's all about rebuilding the population, lots of conservation initiatives. Koala happens to be a species that fairly tame. doable, that's where you can bring some captive propagation. That's a term. We'll have to see somewhere, maybe a final. Captive propagation is a very effective. Captivity and release. You said koala, and then you said, and the giant panda, there's the red panda as well, that's also more enigmatic, smaller, therefore not even here. Not as easy but, this is the perfect course to talk about ecology of these species because the human component is so big that only wildlife. I talked to many of you in the school we're talking, I can never touch the human side part of the ever. Therefore, wildlife management is a big component of wildlife ecology. You understand that, right? We're a very big mammal. I'll remind you that the typical size for a mammal is the size of a mouse, 3 grams, and we're you realize that when you go, as I said, picking from big, there are cities where pyramids are taken over. There's only 5 of them to kill technically, and these things are ferocious. They only need 10 kilos, we have 52. We have warfare, we have weapons, we have green. Can't coexist. That's the idea. That's the whole point here. Right? Coexisting in this part. They're stuck somewhere in the abyss by the Titanic, somewhere 2 miles down. Or now we don't care. Right. So, cool. One last example, and then maybe we can move this course forward. Yep. The cormorant, yeah. Interesting, almost falls into the category of blackbirds. That thing extremely successful. People mentioned blackbirds earlier, right here. I think this is the blackbird. For some reason, and that's pretty cool. The darker forms of a given species, say, melanistic forms like the black squirrel, blackbird, they're very aggressive. People in animal husbandry, like in an animal care facility, raise mice and bonus question at the exam: why are the mice white in the lab? Because the black one like more than the white one. Okay. Don't ask me any further. I don't know the connection. There does this trend that black animals tend to supplant, just overcome other species. So the cormorant is one of them. Very aggressive. It comes to its little hair and nest and just nags forever until it's American. Of course, right away we're thinking competing. People, anglers in Ontario see, raise your hand if you know the word Zilda. Anybody? Good local. So there's Whitewater Lake and there's cormorants on it. There's the cormorants on Arthur Lakes, by speed. They're taking over, and anglers are afraid that the fish stock is going to wrong, but if you're trying to stop, they that's right, and if they don't bring in adults, they stop at 5. So, I'm gonna call it invasive species. So whoever mentioned the black animals, they're invasive So black squirrel, same thing. The only thing we couldn't take was the harsh winters, but now we have it in Sudbury. I'd say 20 years ago, there was no black squirrel out there. What's coming up tolerates the conditions, but it can take over. The height. So redwood, blackbird, the same thing with all kinds of other species. The cowbird's another one. Anyway, so cool. Thank you very much. Opens my eyes to wildlife, ecology, wildlife management. So the last the chapter 1A was about units of scale, trying to just bring that to your mind, and that way you can break it down and see what scale we're talking about. So we talked about the individual population, ecosystems, biosphere. Those are scales, right? In wildlife management, we can't, it's very hard for an ecologist to come in and say, I'm gonna solve the white-tailed deer. Okay. I would like your problem. To solve the problem, it's very rare that you're gonna approach the target. Therefore, the key in management, the first things first is definitely population. I mentioned that already, that it's gonna stay with you. That means that our studies in wildlife management are always hopeful. The focus is, I also call it autoecology. I mean, sorry, I'm a deer ecology, I'm a deer biologist. About deer bio, solving the deer in abundance. So if there is 0 animals, there is no wildlife management. So, and if there's too many, there's definitely a wildlife management. So actually, if there is 0 and it's desirable, we can decide to increase it. So it's about population. Population is the word that belongs to every species. Is what's around it, the deer versus the moose, and so on. A little harder to do. I don't know too many people will say, well, the only solution to help the deer is to take down the moose. Although we know that the moose is not beneficial to the deer. Parasites, for example, nobody will target the moose. You can target the plant because it's food for the deer. So then you approach community. You understand that? So population is the first thing. How many are there? What are the trends? Past, current, and forecasted. So that's a key for many biologists, is not only find out how many there are now, but find out how many there were, and how many there should be, and how many will there. Right. So past, present, and future in abundance. So there's more knowledge. I mentioned that already, but there is definitely more studies, more knowledge, more interest, more background in population ecology than community ecology than ecosystem. Population, you focus only on the deer, you measure everything you want on the deer, and then you go beyond to add some extra. But if you're a deer biologist, you're probably not a moose biologist. Eventually, you can become both. So I'm going to start. I'm going backwards. We started with the biosphere and all kinds of ecosystems. Remember the biome, the desert. Well, we're bringing it down to communities right now, and then finally population. This is the way I've been teaching it in the second year, and my small brain, don't see a reason to change that. But try to separate that in your brain. Okay, so ecosystem ecologist has a different target than population ecologist. In this course, population ecology is the first things first. Definitely you need the numbers on the animal you're trying to manage. But then once you got the numbers, you can look at its environment. So you want to know what kind of a relation it has to you or to other animals, right? So you're looking at given species, and you need these terms for the exam. A whole bunch. I can define them very quickly, and if you need clarification, just raise your hand, start screaming, or take off your mask, I'll be alerted right away. Hello? We're not even connected. Maybe we are.
I think you are, but I don't think you're sharing your screen, so you can't see what you're doing.
I think I had a problem with Zoom. I couldn't connect it. I don't think I
It
connected.
was recording when we got here.
I'm not connected. I'm not on Zoom right now, am I?
Yeah, sure.
This one, bottom, the blue
The
corner.
blue one.
It's recording.
It's recording.
Yeah,
We gotta share screen.
so we can't see what you're doing right now.
Am I
So
Right.
if you hit full screen on the Zoom,
right here? Full screen?
Let's minimize.
or just pull it up and. you can
It's
see
just
it.
my finger, so, yeah,
So on the bottom, it will
There it
say
is.
share screen, and it's the green one,
yeah.
and then it will share your presentation, and then you can choose presentation
Yeah.
in the bottom.
Yeah, that's where I was. Thank you very much. I'm just half an hour late on this. You guys, why do you think I need 44 people in this room to help me out in protection? Thank you. All right, so let's go back to the material. So of course, there's a bit of memorization. So I want you to get a little technical in the exam in terms of calling and whatever. So those terms are important. I never ask for definitions. I go the other way around. I'm going to say the relationship between animal and human is zero. Yeah, plenty of examples. Animals that don't matter so much to us, you know. That's the problem. I'm trying to think. There's some gases, for example. So that's established. That means humans will not have an impact. Mutualism is positive for the animal. If the animal is mutualistic, that means it enjoys your presence, but you don't care. Is that right? Am I right? No, I'm sorry, positive, positive. So mutualistic is not mandatory. That's the difference between, you know, the other term, somebody's gonna give it to me. We call a mandatory, positive relationship between two organisms. Plant and plant. Symbiosis, thank you. So you know that term already? It's just, that one is mandatory, so cases are two. But there is many cases of plant animal, for example, or plant, that benefit from each other's presence. But it's not mandatory. I can think in my little mind, simple mind, I can think of raven, vulture. Ravens survive very well alone. Vultures survive very well alone. They get a better food rate when they see each other, because they watch each other, they take the information. But it's not mandatory. Therefore, it's not symbiosis. It's a mutualistic relationship. So as soon as I said that in my mind, I'm thinking, oh yeah, okay, so it's positive for each, but it's not mandatory. I can't think of a human. If you can think of an example, I'll be glad to listen. Commensalism is when most commonly from the human perspective, this is the perspective we're taking here, is when an animal is in your area, you know it's in the area, but you take no action because it doesn't have any effect on you. So that's zero for a human. That means I don't care. If I see a mouse in a camp somewhere, I don't need to run at it. I don't need necessarily, you might want to do that. I'm saying there's all kinds, you can take domestic plants, or if I'm not sticking to wildlife here, but I'm sure I'll example. A species that enjoy your presence benefits. I I'd love to think that the red box is commensal to human. It's not the best example because people want to shoot it right away, but otherwise. There's farmers who coexist with wildlife all the time. And then me came into my dog pump and they do nothing about it, therefore the relationship commensal. I take it my budget and say, I'm going to lose 10% my week every year. Sorry, that's. So commensal, positive for the species who comes nearby. Maybe I'm thinking apple orchard, where deer comes at the fringe and the farmer knows. There's nothing about it, the fence won't work. Then, you know. And take the animal away from that area. So there's a assumed loss, 10% to deer. So that's a different story. I'm thinking, of course, from the human perspective. I'm not thinking of the deer that needs to be around, that we want to increase numbers. Competition negative for each, that's an easy one. The key for the exam is to absolutely mention that you need a limiting factor. So it's not in that table, it's gonna come around. That's really essential. I would give the example of the honey tips. Where there's 10 customers and 5 honey tips. If I don't mention the number of honey tips, I don't care how many people are there. There could be 2,000 people, or 3,000 honey tips. We're still good. Zero competition, all right? So it's negative, and that's why competition, first of all, negative is not good for biology. It means other humans are going to suffer from too many wolves around, and there's no more. So humans might suffer from competition. It works enough, and we'll put them all. Competition. That phenomenon of forest biologists study competition quite a bit to try to see how it works. And the idea is that eventually competition will resolve itself. So competition is always temporary. It might come again every 3 days, but it resolves itself because it takes down the users. So either let's think deer moose, for example. If you know the same thing that's rare, one of them is going to suffer and go fewer numbers. Therefore, there won't be any more competition. I gave the example of the lineup at Timmy's. There's only 5 honey tips, 10 people. There's a way to solve that. Talk about customers. Don't do that at home. Breaking legs. My size intimidation doesn't work at all. So you could bring confidence. Sorry, put in the right one. So eventually, there will be a resolution. So some people will leave starving, for example, but no matter what, numbers are going to go down for the users. I mean, seldom I mentioned just because it's in the textbook, never heard of too many cases where our sole presence will affect negatively species. And of course, we think of pollution and so on, but that's more indirect. The kind of effect we might have on a species is not clear. I was tempted to go into animals. Yeah, what is that?
Like if I see a spider in my house and I want to kill it, it's not doing anything to me, but I'm killing it.
If you're killing it, it's probably because you didn't like it living. You like it
Yeah,
better
but
dead.
it's not actually affecting me,
No,
but I'm killing it. So would that be a message?
I'm thinking of an animal that comes in humans, close to humans, because the negative is on the animal.
Oh, okay.
The zeros on the human, so the human doesn't care. And then all comes in and says, you know what? I don't like that scent. It's probably tax or something like that. I gotta go away. And people, the animals turn around, yeah.
Maybe geese.
Canadian geese is totally commensal. That animal is an animal that benefits from humans. It eats our grass all day long. Number the reason there could be 20% of the current goose population, Canada goose population, is due to our feeding the geese. From all the way to. These animals like what we produce. They don't care the pavement. You notice that they seem to cross the street with no trouble. Very commendable. Red fox is on campus, always been around. Do you care? No. It's a nice animal to watch, so we certainly tolerate it, but we don't have a direct interaction with it. So that animal is commensal as well. Here I go back to commensal, and we were talking about commensal. So an animal that's really shy. In other words, think of an animal that's really shy. Yeah, yeah, that's all in pollution. It's not the butterfly that wants to keep away from humans. It's our very, very large territory, so it's not very small. Yeah.
Mentioning southern terrorism and how humans, people should raise it, means that they might not agree with it.
Because people are.
Sorry, you mentioned the other southern terrorism in southern, or as a big, people trying to move on the drinking lizards.
I don't mind that at all. Many animals who, so we cannot tolerate the proximity. By proximity, longer is proximity of both. Will not tolerate the proximity of humans for at given time. My group, the Martins, the females, there's just no way female will get birth by a cat. To go away, and the minute an ATV goes by, if that animal is having pregnant, that it's only a period of time that the rest of the year you might see it around. So I'm still looking for a good case. Yeah.
For like the turtles crossing roads. Like the driver will have little to no
Yeah.
effect or care about the turtle.
Yeah, that's habitat. But the turtles are not fleeing from us. They're not running away from us. I'm looking for an animal, but we'll come with some case at some point. If an animal's really, really shy. I was hoping that Wolverine would qualify, because and even the wolf, actually. The wolf is a very shy animal, right? Of course, in numbers and hungry, that's a different story. But even hungry, if they have a choice between turning left, hoping for a moose, and turning to New Sudbury where there's garbage, the coyote will go for garbage, commensal, and the wolf will turn away. There's no way of bringing pups near New Sudbury. So, and of course, there's site fidelity, so your pups have known this area, so therefore they were born in the bush. No contact with humans. It's tricky. As soon as you hit the provincial park, your behavior changes entirely for the animal, right? It was shy, now it's not shy anymore, kind of deal. So very tricky to analyze. So of course, it's not in bold because we're going to focus this course on 3 of them. So commensalism is, can't help it. We're approached by animals. Keep that in mind, right? So that's when an animal approaches and we didn't call it, we didn't bait it, we didn't lure it. The animal likes what we offer. So commensal is certainly a good example. Red fox is a very good example. The house mouse is a very good example. For fun, let's talk about it. Yeah.
Raccoons in Toronto.
Yeah. Yeah, yeah. So, but there is management, correct,
There is.
right? So, I said zero in commensal species, okay, we don't bear so much unless get 3,000. The day we get 3,000 cancers, I think we will manage. Right? So keep that in mind as well. So commensalism is the reason why we're in contact. It's the reason why we're in contact with the animal. Because the animal likes us, likes our grass. You wouldn't, I mean, you see loons on your on your lawn, no. Don't like what we offer, right? So commensalism is pretty widespread in many animals, and it forces an interaction between humans, and because it brings the animal towards the human. Competition is a problem for sure if historically, I mean, and the story would repeat itself if tomorrow we were short on food, guaranteed. If there's too many wolves and we want moose, we need moose for survival, guaranteed the wolf is going down. That's competition. There's only one moose for two populations, not good, right? And that's only one example, but that's day in, day out. We might want to, that's beyond the topic here, but I mean, farm ecology becomes a topic. As humans, we decided not to fight the biodiversity around us and create our own food sources. That's called farming. We used to be gathering, we were tired of walking, said, no, I'm staying put. I'm gonna build a house, nice cave right here, and then I'm gonna grow some rice, whatever. So they brought in some wild rice and cultivated and so on. So we seem very, very good for the planet because we're saving all the wildlife around, right? We're not killing the wolf in order to get the moose because we have beef on our shelf. So you realize I just opened a can of worms. Farm ecology, in terms of saving the planet, is a different game altogether. Different game altogether. Lots of damage being done by farms. And unfortunately, this is not the place to teach farm ecology because compared to the rest of the planet, we got about 0 farms. I mean, sorry, Anneli, for Manettville. I know Manettville is very productive, but go on YouTube, go see the super machinery for corn in Kansas. Good luck with that. The video is 45 minutes, but it feels very big. Goes on forever. Super machinery. And it's almost packaged at the end of the machine because they need days in order to collect. So you looking at kilometers of field, uninterrupted, straight up as far as you can see. Nothing like this in Sudbury. Our wildlife management has to do with forest and water. That's one. So competition very important. I mean, seldom we pass. Parasitism is mentioned often in wildlife management. When I hear of bird flu, any kind of epidemics. Again, we're talking as the wildlife that is at the interface of human, not the odd one. There a lemur somewhere, nobody cares so much, but if we're still talking ring-tailed lemurs coming into town, then parasites become important. If the population is going down, maybe we help with the parasites, the parasite load. And otherwise, yeah, the parasites might explain the population decreases. So I'm not mentioning this one right here, but predation is important. Of course, that's very common in terms of wildlife management. I want to help the deer, I solve the predator. All right. And of course, we are predators. I hope you realize that. I hope you realize that we are predators. I swear to God, if we close food basics tomorrow because of a pandemic, everybody's going on deer. And we have to feed Toronto because they don't know what a firearm looks like. Oh no, they do. They just ask Miss Saga, see what's available. No, I'm not being racist or anything. So, yeah. You see how I make a very long story just to keep your interest, but there's 4 terms here to remember, and the question, the exam is definitely about species interaction. What is the nature of the interaction? Well, it varies on where the benefit is or the negative is. And they have names for it, so I need a list at least of 4, and I'm sure you want to focus on the yellow ones here. Yeah. Picture of me before I shaved. So you should be able to see something, but we don't. Maybe I can't use the full screen for some reason. So competition, of course, that's a clear. I'm sure it's not clear to everyone why we should be taking down moves, but please keep an open mind. Outside your, your 20s, when you have only driving only a Civic, and at some point you get a full-size truck, and your buddy is going out in the bush and you need something. And it fills your freezer for inviting people from Toronto to take some excellent moose meat. It's still being used, whether you like it or not. So it's a natural resource. And there's no zero tolerance on this. There's just no way. So the idea is to find the proper balance. Firearms in the bush, sure, of course, Gary wants to take a move. But tag, not too many. So the industry allows, but monitors. So competition. Same for wolves, of course. Historically, that's what happened to wolves. It's not because they're ugly, right? We took them down because they're competing. And of course, they're predators as well to us, right? I mean, you don't want, if you know there's wolves around, you don't want to leave your kid in the backyard for too long unattended. Ammentalism, no real example so far. Predation, there's a whole bunch. Predation is complex because you can see right here that we have Canadian species are all over the snowshoe hare. So always question the exam, what species don't you want to eat ever? And that the answer is the snowshoe hare. You breed like a rabbit, correct? And then they'll die. The weasel get at the nest right away. And those poor adults, an old snowshoe hare in the bush is 2 years old. Everything happens really fast. It's actually really fast. You produce a lot of babies and they're seed around. And then they die. So dramatic changes in the population levels in the snowshoe hare. And suddenly changes the whole picture for the lynx, of course, you can imagine, or for the wolf. Wolf has alternate species. The lynx happens to be just the size for a snowshoe hare. A red squirrel won't cut it. Moose won't cut it. Has to be snowshoe hare. That's why we know about this typical, very well-known cycling of lynx versus snowshoe hare. If I'm raising issues that you don't know about, we'll be happy to talk about it. And again, I showed 3 predators for purposes because it's not just only 2 species. So if there's a food source somewhere, as soon as you mention predation as an acting agent on the population, you've got your work cut out. And in terms of parasites, we could think of a couple of examples, I guess, of wildlife. But I want to be careful with that. I want to think of careful examples, and if you have, you bring them up. I just want to give the definition of parasitoidism. I can pronounce this right. Parasitoidism. Pretty cool. So you heard the definition before. It's parasite of a parasite. So parasite human, then anything a parasite that tertulant is a parasitoid. Second level, first, second level parasitism, second order. And again, the very few examples, again, this is textbook material, this is not, if you see question mark, that means there is no material for the final section, again. In a few years, commensalism, of course, all kinds of species benefit from our activities. I could think of a whole bunch, how about, and that's pretty extreme because we're in Sudbury, but how about the mines warming up the lakes and what are the lakes in Sudbury? What do we have for lakes? Too short, anyway. Ramsey, yeah. Beto?
Better and Netflix. Better and Netflix.
Yeah. Thinking. I see your lab report then. Yeah, Nephilim. What's towards Lauren? Oh, no, it's not Long Lake. Hilly Lake. There you go. Hilly Lake Road. Raise your hand. Hilly Lake Road. Stop breaking. So, by Hilly Lake. Typically, it's been used to dump all kinds of water from the industry. And of course, it's being remediated as much as possible. There's deposits and houses on that lake, so that the water has been removed. And one solution that we didn't see coming is the warming of the water. Therefore, we now have resident duck population who should be down in West Virginia, but they have open water and they stick around. Nice simulation for global warming. By the way, what would happen in the lake zone 3 in Sudbury? Oh, we're talking a change of picture. Suddenly there's a bunch of migratory species who will think again. Landscape will change for sure. So yeah, all kinds of species beneficial. If along the course, if you think of other examples, I'll be glad to listen to you. Mutualism for sure. Then we get into population country. So I made a very long story for a very short summary. That's all I need for the exam. So first things first, the population in wildlife consist of individuals. In other classes, if we teach plant, for example, it becomes tricky. You look at one cattail and suddenly the next one is connected to it, the same genome. What do you do? But then again, you get out identical plants, the same genome. So, but they're still two individuals. So it's quite tricky in some instances. But let's keep it simple. Instead of being modular like this one, our animals in wildlife are countable. I can count. You understand that if I dive and I see this, I don't know what to count. Is there one leaf connected? Is it part? Is it an arm of the head? And so on, right? So unique individuals. I can mark one with the paintball gun, and then I'll retrieve it. No, don't do that at home. Don't start marking animals. So of course, the population is a group of conspecifics. A good term to use at the exam. Conspecifics, just to be technical. Of course, con means together, and specific for the same species. That means a whole bunch of animals of the same species together at a given time, a given location. Time and location is always part of the definition. That means we drop everything that's in the cemetery and we don't think of what's coming up. It's either given time, given location. So people will refer in Sudbury, near Sudbury, they will talk about deer. And I think it will talk about either the lowering deer population because it tends to be delimited. Of course, it's a continuum. We have deer from Lake Nipissing all the way to Florida. There's not a spot somewhere where there's no deer. Yet they're not all connected because suddenly there's a barrier or something or a corridor. That limits the exchange. So the genes of Sudbury, the chances of genes of the deer Sudbury to go down to Florida, we'll have to wait 1,000 years before that gene flows all the way to Florida. So there are units, they're called population. We do our best. Often, if we can't limit the population, at least we're gonna stop where the political boundary stops. In other words, Sudbury manages for Sudbury, Ontario manages for Ontario, Quebec manages for Quebec, and so on. That's called political boundaries. That's the best we can do. Because if the population is a full continuum. So snowshoe hare is a good example. That's an animal that's called, anybody wants to go fancy on me and give me the name, the qualifier for a species that is everywhere. Two terms possible. Adam. Ubiquitous good or cosmopolitan, right? Those are equivalent. No. Snowshoe hare is a Canadian species and it's the first thing to be mentioned because it's everywhere. There's no reason to think that the gene pool doesn't travel. Now, there's a bunch of. Well, sorry, before Zoom even. And 22 authors on the paper, I have never seen that before. 22 authors got together from BC to implement to find out if they have database on how many they have. And they discovered that the cycling, the highs and lows, are organized into a wave. That means that there's a kind of a ripple effect from one end to the other one. So there is a connection between, that's the best I can do, is tell you that it's actually one population, that they are connected enough that the effect of one population creates an effect on the other. And I mean, it's just one continuum. So a little tricky, right? Gotta be modest. Talk to a Wisconsin biologist, we manage bobcats. Okay, sure. What about the next state? Sorry, we don't know. They have their own jurisdiction. You understand that this is the wildlife manager right there speaking, answering the person who's right at the border between two states and says, my deer is going down, what do I do? It's part of the reality for sure. So definitely applied ecology in this case, because you have to deal with Uncle Jerry, who's sorry for himself. So long story, right? I mean, that was just a definition, but population, when you apply it to wildlife management, that's where I want you guys to go at the midterm, to apply the concept population to a context of management. So I mentioned political boundaries, delimitation of population is a challenge. I could argue, if I worked for a larger unit agency like Wick or something, I'm gonna try my best to phone Manitoba and say, listen, can we come up with an agreement here on this and that, kind of the goose or migratory birds and so on. Part of the job. Wisconsin is paid by Wisconsin, therefore it stops at Wisconsin, right? So you need larger agencies to bring them together. You can look forward in 10 years to see worldwide initiatives, because of the connectivity we have, digital, the access to databases is absolutely unbelievable. I can see in 10 years having a worldwide initiative, just like we're trying to do, with not so much success with the greenhouse effects and global warming, but at least, right? At least we're trying to bring it together. That would be a good thing. Very important in international species, whales. Pure hell. You tag an animal in the St. Lawrence off below Quebec City, and that thing flies all the way to Japan. Guess what? They like whales out there. Lose your tag
in some individual's stomach somewhere.
And if I said China, I meant the east. I'm not pointing to a particular country. Indonesia and the east have been traditionally very avid of seafood, including whales. So, not to mention all the cultural belief that they have about aphrodisiacs and so on. So it gets really complicated, but they're still out there. They will shake hands at a summit and then go back home, and the population is hungry. You know how many people in China? Just to name one country, I mean, Indonesia is covered with people. So the shoreline of the ocean is, it's one shack after another. They all feed their families straight out on their little boat. This is the common life for these people. They have to target their natural resources, and they like whales as well, and octopus and so on. So there's a world out there, I swear. More and more, this is a little more recent. Population has been known forever, of course. We established that a long time ago. Meta population is a little more recent. Is meta means secondary or second. So you have a population, but people realize that it's surrounded by other populations. Then suddenly the new unit of two populations somewhat connected. Did I say it's connected? Yes. Have to be connected. But if they're connected, I don't need the possibility of connection. I'm talking gene flow. No, so ultimately I want to know if the flow of the thing is going. So is that from a moose, no breeding, it's not a connection. If you go back to the, you know, connectivity is mating, change genes and so on, so that they're somewhat mixing. There are the odd moose who will take off for the next population and breed, and then that's a meta population. So very important to realize that if you work on this one right here, I'm pointing to this right here. So this population, you see the little dots representing individuals in there. So keep that in mind for the. Did I just do that? Maybe. Maybe I just did. So each white circle represents a population. The arrows represent the gene flow. Notice that it's small or larger. There are small arrows, larger arrows. If you can interpret this at the exam, this is already good. So those elements explain what a meta population is, of course. So I need a bunch of populations. I represented 3 or 5, 6, 7, 8 on this side of a road and 2 on the other side. So I have 2 possibilities. I could ask if the 10 dots are a meta population. The answer is no, because there's population that's totally disconnected from the other. So I got 2 meta populations in this graph, one right here and the other one right here. This one's composed of 8 populations that are connected to varying degrees. So seed picker arrows for more gene flow, and I could have shown little dots. There's animals that there's just one individual that travels. Wolf is a good traveler, so often you'll have this odd individual who leaves. It says, I'm leaving home, that's it. Takes off for 100 kilometers. They can go 100 kilometers, and then they'll make friends with a new population. Of course, we're talking mobility, right? So this is on a physical space, so these animals have to travel. So that's a concept. You see a bunch of definitions. That's why it's called concept. Habitat is another important feature of populations. They have to live somewhere. the definition of habitat is of course the set of conditions necessary for survival and reproduction. Repeat this, so it's a set of conditions necessary for survival and reproduction, which is called fitness, right? So of course, there is varying qualities of habitat, so therefore the fitness of the animal. So the deal, it's like for you and me, trying to pick the best set of conditions for your best habitat, for your best fit. So, 10 kids at home. Same thing for animals, of course, same idea, so. Best pick the absolute best habitat. Right, habitats are, might be occupied by dominant individuals. So. In humans, the winners are those are the richest, I suppose. I mean, I don't think I could buy any millionaire's house anytime soon, so I will not dislodge, and he probably has a better habitat than mine. Although I have hot water and hydro. So habitat is not simple. So as a wildlife biologist, as a wildlife manager, you want to know. Hopefully, there's biologists who work for you and you have that database already. But otherwise, you have to plan a team to go out there and see what the habitat is like. Here it's so common. So habitat is important. Keep in mind for the exam that there is different scale to it. Well, again, it's just me and my elbow. So geographic, try to memorize these things. They come in a certain order. Geographic is, are you at the 46th parallel north? That's your continental scale. Local. Here I got two examples for Sudbury. Sudbury itself is on rocks, you know that. But if you live 20 kilometers away, you're in a valley. It's two different habitats right there. The animals have to pick the ones that they like. And then within that, they establish a bunch of territories and then the individual itself. So this is represented right here. I'm going to go very quickly. So this is continental scale right here, called geographic in this case. And then out of this, the whole continent is not habitat because this horned lark likes prairie, open habitat. In Canada, we've got a bunch. Before growing wheat, prairies were prairie. So we had Canadian prairies, they're natural prairies, now much cultivated. Right here. And within that, they have to pick still the best area. Of course, they, again, did I say anything for a set of conditions for their survival or reproduction? So you can think of for shelter, food. It's good to bring in the exam. Shelter and food. And we're gonna add mates as well. So again, a single animal could be full, but it won't make a population if it doesn't have it. So these are the conditions that they try to defend. They defend an area that has the conditions as their proximal habitat. It's called individual habitat, where there's food, shelter, and then mates. And the animal will eventually defend this with this area. So within this area, he wants to defend it. You don't want to walk the perimeter all day. So instead, the animal will pick key spots and defend from there. Animals do it in the bush. Your dogs do it if you walk your dogs. They always pee at the same area. Raise your hands, anybody? Dog that pees exactly at the same spot every time? Yeah. In the bush where I have wildlife cameras, the lynx do it. I've seen them do it on very quick clips, 10 seconds. It's not only the same corner, it's exactly the same shrub. So that poor shrub, I don't want to be a shrub then, because it's receiving a lot. So These are the 3 green spots within the territory where the animal spends more time. Think of an American robin on your lawn, same thing. They'll travel and pick key areas to sing, just because the sound travels better. They can see what's coming. All right. Again, long story to describe these. 4-tier level, you can't just say habitat or it's just a set of conditions. No. You have to know the context. So again, in landscape ecology, if I see an animal right here that has a territory, very good territory, but the surrounding it. What's the term I'm using in landscape ecology again? If it's not habitat, the rest is crap? No, not this term. What do you call the rest, the surrounding? No. Technical term that we use in landscape ecology, talk about the rest. So I found good habitat for the horned lark, but the rest could be just. Yeah. Nope, nature. The word is nature. Very technical for landscape ecology. You'll see one very hard to spot, this is what we're gonna be dealing with, so you'll know the term for sure with the final. And this is what this represents. It's not that, but it's not that I see an individual horned lark. I don't have population yet. I have to see what's beyond. I'm looking at the habitat of the animal, I'm looking at the matrix. And if the matrix is good, check its habitat. I'm increasing, I'm getting more habitat. The idea is to look beyond, basically. That's your matrix. What is it set in? I mean, give you an example. Sheep. The humans make beautiful natural experiments with that, where the guy has bought 30 acres and he wants to have sheep. Happens to be in Noelville, surrounded by a mature forest. What chances the sheep are going to survive? I hope the example is clear enough that there's coyotes lurking around, 30 of them. Say, Jerry, there's a new food source there. I swear to God, they're all white, all fluffy, beautiful. They die, they don't make a sound, they don't fight back. But we're going in, Jerry. All right, so that's exactly what's happening to these animals. For a wildlife manager, very important to know. If I work on the moose in Sudbury, what's beyond? What's in North Bay? What if you're putting down your animals in one area and the next guy is doing the same thing, the next district? So you have to know what's happening. How do you protect Algonquin Park when there's firearms every kilometer around it? I think the matrix is not so good. So the solution for Canada was to create one park, the oldest park in Canada was Algonquin Park right here in Ontario, to make it huge. Therefore, you want habitat? Yeah. I don't care for the matrix because there's enough habitat, right? So the wolf, for example, wolf population that we're trying to make sustainable as much as possible. I think it's working, but I'm a little sensitive. I'm almost done, guys. Let's see, am I done? I'm going to stop right here. Thanks for your attention.
Oh,